So these two common right triangles here have patterns associated with them that allow you to find all of the measures if you only know one element. Okay, so with Pythagorean theorem, you need to know two lengths. Okay, for these two patterns that we're going to talk about in these special right triangles, as long as you know one length and you know what type of a triangle it is, you can find what the other measures are by using the following patterns. And so I'm going to derive the pattern first, and then I'll talk about it. I mean, it's up here where you see it, but let's say you have an isosceles right triangle, okay, meaning that you have a right triangle with two equal sides. And that means that one side is equal to the other side. So we'll call them x. We don't know what it is right now. It could be any value. And then for right now, let's call our hypotenuse c. We can find an expression for c, the length of that hypotenuse, in terms of x by using Pythagorean theorem. Right? So a squared plus b squared, the sum of the squares of the two legs, is equal to the hypotenuse squared. So if we added x squared plus x squared together, you would get 2x squared. And so now if we extract this root, the square root from both sides, again, we don't need to worry about the negative of the roots. We get the square root of 2 times the square root of x squared is just x. And so this is your c value. C is x root 2. And this gives you the patterns that we're looking at here. If the length of each leg is some unknown, the hypotenuse is that length, the length of the leg, times root 2. Okay, so the pattern of lengths in a right triangle, or a 45, 45, 90, or an isosceles right triangle. Again, this could be called an isosceles right triangle as well, okay, is x, x, x root 2. And you should know this pattern. Okay, you shouldn't need to do any calculations when you're answering questions with these special right triangles. 45, 45, 90 that we're doing now, and then the second one we'll do is a 30, 60, 90. They're both based solely on patterns, and if you understand the pattern, you can find all of the measurements just by looking at the problem. So if we look at this first example right here, if we have these 45-degree angles, and again, you're either going to see that the two angles are 45, or you're going to see the markings that indicate that the legs are equal. And so you're going to find that it's an isosceles right triangle in one of those two ways. And once you know that the legs are the same length, and the hypotenuse is the length of the leg times root 2. Okay, so if we were finding being asked what is the length AB, if we're given 19 as one of the legs, what would the length of AB equal based on that pattern? X, x, x root 2. So we know that x is 19, which means the hypotenuse has to be what? Well, if x is 19, the hypotenuse is x root 2, then our answer is going to be 19 root 2, right? It fits that pattern. We have x, x, x root 2. If x is 19, we just substitute that right in, and we get our answer 19 root 2. And what if we have this pattern and they give us the hypotenuse, and the hypotenuse is in that pattern form? So if we look at this second example, we should be able to identify the length of each leg, including what BC is, just by looking at that pattern. So if the hypotenuse is 21 root 2, what does that mean the length of each leg has to be? X, x, x root 2. Well, we see from the length here that x represents 21. So that means the length of each side will also be 21. So BC is 21. And you get your answer just by looking at that pattern. All right, questions on those two. Those two are the straightforward and basic patterns, okay, that it should be almost instantaneously. You should be able to see what your lengths are. All right, this last one is the one that's a little bit tougher, just a little bit more challenging. Okay, if you remember a pattern, it's super easy. You can also, because this MyOpenMath system allows you to enter a calculation as your answer for a lot of the times, you can also enter this as a calculation based solely on the pattern. Okay? But if you are looking for how do you turn x root 2, how do you solve that for x? Well, if you were to say that x root 2 is equal to 13, right? So we know from this pattern that the hypotenuse, x root 2, is equal to 13. So what would we have to do to both sides of this equation to solve for x? Just undo. What would we divide by? Root 2. And that is your answer. The length of each side is going to be the hypotenuse divided by root 2. Okay, now, because in this MyOpenMath system, we can enter our answer as a calculation. That's all I need to do. 13 over root 2, there's my answer. Okay, now, that's really what we did over here as well, right? We had the hypotenuse is x root 2. That's equal to 21 root 2. And so if we want to solve what is x going to be, divide both sides by root 2, those cancel, and we get our answer 21. So we did the same thing with this more complicated problem as we did with that more straightforward and simple problem. Right. There's another way to think of this pattern that you will often hear, because sometimes you're going to be asked to write your answer in reduced radical form. And we haven't talked about what that is, but it represents that you can't have a radical in the denominator. So 13 over root 2 is fine for a calculation, but if you had a question that said write it in its reduced radical form, you would have to rationalize the denominator on this. And so there's another pattern that works for this if you would rather use it, and that is if you want to express this relationship, anytime you divide by a square root of something, it's equivalent to dividing by the number inside the square root and multiplying by the number itself, that whole root. So if you had something like this, x divided by root n is equivalent to saying x divided by n times root n. And so what you could have done for this is you could take your, if 13 is equal to x root 2, you could say that x is 13 divided by the number inside the radical, 2, times the radical itself, root 2. So these are equivalent. You guys don't need to write it in the reduced radical form, but next year when you do unit circle stuff, it's very likely that you'll need to be able to put it into that form. So I just want to, again, expose you to that as a possibility. All right, so on your homework, you're going to see these types of practice. So your practice is going to be, you're given a leg, and you find the hypotenuse. You're given a hypotenuse, and you find the leg. You're given a hypotenuse that's not in that radical form, and you find the leg by dividing the hypotenuse by root 2. So these are really the three sort of patterns that you are responsible for knowing. Now, extending these patterns and being able to solve some story problems or word problems is sort of the next step. Okay, so I want you to try this top question right here. Okay, can you answer this question based on using the patterns of a 45, 45, 90 or isosceles right triangle? So again, ideally when you're working with this problem, an isosceles right triangle is half of a square, right? Cut down the diagonal. So if you see these consecutive bases in a kickball field are 54 feet set up in the shape of a square. So if you have a square and one base to the next base is 54 feet, that means that each of these lengths is 54. You create this square. Okay, and if you say, here's home, first, second, third, okay, and again, if you're not familiar with how a field is set up, it just tells you opposite corners of the field. So if we're looking for this length right here, I'll call it C. Okay, so here we have this isosceles triangle. Bases are set for this square is squared off with this right angle. So what we have right here is a 45, 45, 90 triangle with legs of 54. That means that hypotenuse is going to be what? X root 2, so 54 root 2. There's your answer. That's all you have to do for that problem. Okay? See how it fits in the pattern of a 45, 45, 90 triangle. Right. There's an alternate version to this question. Okay, see if you can find what the distance between bases would be if you are given the actual diagonal. Right, so we have the same setup, right? This square field. Here's home, here's second. That distance is given as 121.62 feet. And assume it's set up in the shape of a square. What we have is this isosceles right triangle, or 45, 45, 90 triangle created, where we know that these side lengths here, these legs, are both the same length and it's some unknown length. But because it fits this pattern of x, x, x root 2, we know that 121.62 is equivalent to the pattern x root 2. So if what we need to solve for is x, we simply divide both sides by root 2. Here is our length. And when we plug that in, we'll get our approximation of about 86 feet. Okay, but that is the calculation for this problem. Okay, so as long as you know that pattern, x, x, x root 2 is the pattern for for a 45, 45, 90 triangle. And once again, if you forget the pattern, because I'm going to give you a second pattern here in just a moment, if you forget that pattern, just recreate it really quickly. You have x and x, so if you took x squared plus x squared, the sum of the squares of the legs equals the square of the hypotenuse, 2x squared, extract your root, you get the square root of 2, square root of x squared is x, and so you can create this pattern here very quickly. At any time if you forget and don't memorize the pattern. You can recreate it easily as well. All right, so those two slides were demonstrating the types of questions that you'll be asked with regard to 45, 45, 90 or isosceles right triangles. Okay. The second triangle, a special right triangle that we're going to look at, is called a 30, 60, 90 triangle. Okay, notice it's exactly what it says, right? 45, 45, 90 have two 45-degree angles and a 90-degree angle. 30, 60, 90 are 30, 60, and 90. And what these represent is if you took an equilateral triangle. Okay, an equilateral triangle has all angle measures of 60 degrees, right? The sum of the angles is 180. All three angles are equal. 180 divided by 3 is 60, so each angle in an equilateral triangle is 60 degrees. If you cut that down the middle, cut it in half, what's going to happen is you're going to create this half of 60, which is 30, a 90-degree angle here. So the 30, 60, 90 is half of an equilateral triangle. So this is the triangle that you're creating here. Okay, now think about what this is representing. So if we call the leg opposite 30 degrees, which is the shorter leg, okay, the shorter leg is opposite 30 degrees. If that's x, then that means the length of each side of this equilateral triangle, meaning this would also be an x, is going to be double that. So we know that the hypotenuse is 2x, right? Every side length here is the same length, which is 2 times x. Okay, so that gives us these two patterns, right? X and 2x. And that leaves our the third side, the longer leg opposite 60 degrees. And we can calculate that here really quickly by using Pythagorean theorem. So if we said that x squared, let's call this b for right now, plus b squared is equal to 2x squared. And we solved for b. We would first square the 2 and square the x. So we expand it out. We now combine our like terms and isolate the b. So we're going to subtract x squared from both sides, leaving us b squared is equal to 3x squared. And now we're going to extract our root. When we extract the root, we get the square root of 3 times the square root of x squared. And that gives us our final pattern here of x root 3. Okay, now, you can always derive this the same way. So if you ever forget the pattern, you would need to be able to recreate this entire calculation here. Ideally, you just remember the pattern. You have x root 3, 2x. Okay, that is the pattern that you have for 30, 60, 90. Okay, so x root 3, and 2x are your three measurements. Okay, and so what I want you to do is, we'll try from easiest to hardest. Okay, so start with this first one. If you're given the length of the side opposite 30 degrees, okay, that's the easiest calculation that fits this pattern. So I want you to see if you can answer what's the length of AB and AC based on that side opposite 30 degrees being 22. Okay, you will be working with these patterns. On the unit circle, you're going to be using 30, 60, 90, and 45, 45, 90 patterns. Okay, so these patterns are going to occur on the unit circle. So this is one of those things where you want to be comfortable working with these two patterns. Okay, x root 2 for 45, 45, 90, x root 3 for the legs, and 2x for the hypotenuse in a 30, 60, 90. So if you know the side opposite 30 degrees is 22, what does that mean the hypotenuse is going to be? We have x, 2x, x root 3, so the hypotenuse is twice 22, so 44. And the side opposite, the 60 degree angle is going to be 22 times root 3. And that's all you need to do. Again, when you write your answer here, AB is 2 times the x value, AC is the x value times root 3. You can enter your answers as the calculations, okay, and they will give you the correct points. All right, the next easy form of this would be if they gave you the hypotenuse. Okay, because you can still find the remaining two legs pretty easily with no mental calculations really, or very limited mental calculations, if you know what the hypotenuse is. So I want you to see if you can answer the second question here. If you know the hypotenuse is 36, can you find the length of the leg opposite 30 degrees and the leg opposite 60 degrees? So here's our pattern, right? X root 3, and 2x. 2x is equivalent to 36, which means each x is what? 18. And once we know what the x value is, the x value of 18, we can then solve the side opposite the 60 degrees by taking x, which is 18, times root 3. And so there's your lengths. BC is 18, AC is 18 root 3. And we have our answers again just with a quick little application of the patterns. Right, the last example here is what if it gives you the pattern where it tells you the length of that leg opposite 60 degrees. Okay, so see if you can find the remaining two measures if 21 root 3 is the leg opposite 60 degrees. So again, this still fits our pattern, right? So we still have x root 3, 2x. When we're looking at this pattern, 21 root 3 is equivalent to x root 3. And so you can see right here that your x has to be 21. So we can replace 21 here for the x, which means the hypotenuse is going to be 2 times that. And there's your answer. AB is 2 times 21. BC is 21. Now, if you don't see that pattern, you can calculate, set the equation, or set the number equal to the expression. So 21 root 3 equals x root 3. Divide both sides by root 3. Those cancel, and you get x is equal to 21. So you still find that calculation. And in fact, in the next slide, we're going to go through the hardest application of this, which would be what if you get the side length opposite 60 degrees, where the pattern is x root 3, but it's an integer value. And what if it's not in the pattern itself, but what if it's just an integer? And if that's the case, you do this same calculation. Set the equation equal to x root 3, divide by root 3, and that is your x value. Double that, whatever that number is, and that's going to be your hypotenuse. And so I want to see if you can do that before I go through it by looking at this next example here. So when you're looking at the pattern, opposite 30 degrees is x, hypotenuse is double that, the leg opposite 60 degrees, or the remaining leg is x root 3. Notice the piece that you get is the one that's equivalent to the radical, the irrational form. So 8 is equal to x root 3. And so if you want to find BC, which is here our x, divide both sides by root 3, you get your answer. So BC is 8 over root 3, which means 2 times 8 over root 3 is your AB value, and then just answer the questions. 8 over root 3, and here 2 times 8 over root 3. Okay, so you can enter your answers as calculations. You could calculate the values in decimal form and then enter that if you wanted to as well, but this would give you that exact answer. Okay, now, we talked here about what would happen if you needed to find your form here in this form, like this question right here. Okay, what if you were being asked to find the reduced radical form? Okay, this whole relationship still holds true. When you take an integer, divide by radical, it's equivalent to dividing by the base of the number inside the radical times and then multiplied by the radical itself. So here, when we're looking at this problem here, if we say that 8 is equal to x root 3, and we divide by root 3, our x value, this could also be written as 8 divided by the number that's in the radical, 3, times the radical itself, root 3. So 8 divided by 3 times root 3, that would be the x value. So this is another way of writing this answer. And then if you doubled this, you just you multiply the numerator by 2. So 16 root 3 over 3, just doubling this 8 to get a 16. That would be the other way if you had to write the answer in reduced radical form that you would get. And now, you don't need to do those for this class. In this class, you can enter your calculation, which is what I recommend, the highlighted answers. Okay? And so that would be sort of the ideal way to answer the question. All right. So those are all of the patterns for 45, 45, 90, and 30, 60, 90. So again, 45, 45, 90, the isosceles right triangles, the pattern is x, x, x root 2. For the 30, 60, 90 triangles, the pattern is x, x root 3, and 2x. Okay, so those are the patterns that you need to be able to memorize or recreate. Okay, so answer this final question here. It's an equilateral triangle with an altitude drawn, and it's asking you what is this altitude. And see if you can answer that question. Should be able to do it pretty quickly. It's already split up here for you, right? So you see that this 18, 18, and this is 18. That's telling you that these are 60 degrees, and this 60 is divided into 2, meaning that this gets split into 30, 60, 90. Once you see that you have this 30, 60, 90 triangle, opposite 30 degrees is 9. Again, you're given this pattern. I'll rewrite it here. If this is 18 and this is 9, you have x, 2x, x root 3. And so if x is 9, you get 9 root 3. And that's all you have to do. That is your solution.